In this video, we're going to be talking about volume, right? So we're staying with our three-dimensional figures, but volume now is going to move on to, instead of talking about going around the surfaces, we're going to talk about going inside and taking up space inside. So more specifically, you can see in here that I have some water, right? And I have filled the rectangular prism about halfway. And the question is, how much water could we put in here? Say if we were talking about the space in terms of inches, what would be the volume of water in terms of cubic inches that we could put inside of this? Or maybe we're talking in millimeters. What would be the cubic millimeters that we could put in there? You know, cubic millimeters of rice, cubic millimeters of flour, cubic millimeters of water. Volume. Now, what's going to get really nitpicky, and I want to make sure that you understand that I will be nitpicky, is that volume is three-dimensional, right? If I talk about rectangular prisms, there are three measurements, right? There are three measurements. You have a height measurement, you have a width measurement, and you have a length measurement, right? One way up and down, another way left and right, and a third way a depth measurement, right? So this is three-dimensional. So your answers must be supported with units. So remember, 1D, feet, 2D, area, it's two-dimensional, square feet. 3D is now volume, feet cubed. So what you need to understand is the following. If I put 1 foot, and then I wrote 1 square foot, and then I wrote 1 cubic foot, these are not the same answers. So you need to get your units correct. Right? Get units correct. That's going to be part of a correct answer. If you're not sure, ask questions in class. As far as volumes of rectangular prisms go, the formula is pretty straightforward. We're just going to multiply our length times our width times our height, right? And we'll get a bunch of little three-dimensional squares in this thing, right? And so that's what we're talking about. How many of these three-dimensional squares can we fit inside of the whole box until we're full? Or again, how much water can I put in there? So we'll start with number 2. And again, pay attention to the process. You must, right? There's no options on these answers today. You must state the figure name. You need to have practice identifying the figure, right? Identify the figure and then identify the values in the process, then submit an answer with proper units, right? So for number 2, we have a rectangular prism. And volume is going to be equal to 10 times 14 times 4.5. This is where I'm going to go to sort of give you a yes, there's credit for that, yes, there's credit for that, and then lastly, actually multiplying. So what is 10 times 14 times 4.5? That's 630. Now if you write 630, I'm going to take off half credit for that portion. If you write 630 inches, I'm going to take off half credit for that portion. If you write 630 cubic inches, then we're in good shape. Again, 630 is not the right answer. It's the inches that's cubed, not the number 630. 630 cubed is 630 times 630 times 630, which is not what we're talking about. All right? Volume of rectangular prisms, super straightforward. Volume of all other prisms is pretty straightforward, right? But all you really need to understand is that it's just going to be B times H. But notice the B is capitalized. Capital B stands for area of the base. So I look at this base, and this is why I want you to name the prism, because this is a triangular prism, which means that the base is a triangle. So the area of a triangle is 1/2 base times height. And then That's talking about the height of this triangle. Then you have the height of the figure. So the volume for this thing is going to be the area of the base times the height, where height is the height between the prisms. Said height right here is the height of the triangle. This h right here is the height of the prism, or perhaps we could refer to it as sort of the depth of the prism. So understanding the base is the key to the volume formula, which is why I would like for you to put that in your answer. So let's work one start to finish. We have a triangular prism. All right, part one, I've identified the figure. Check. And now the base, as I have identified in green, is the bottom or the top of this figure. So it looks like, to me, that the base and the height are always connected by a right angle, right? Look for the right angle. The base and the height are always connected by a right angle. So it looks like the base of that triangle is going to be this length right here, which is 12. And the height of that triangle is 7.3. So the area, notice I use A for area, is 1/2 times base times height. So that's 1/2 times 12 times 7.3. So first I need to assess that value. Now that's going to be the area of my big B. And the volume is going to be that area of the base times the height of the prism. So this piece here is the height of the prism, which apparently is 5. So I'm going to say, okay, volume is equal to B, which is my answer from here, times 5. Now I just want to finish calculating what this is. Now the way I use this formula is I'll say 1/2 of 12 is 6 times 7.3, and 6 times 7.3 on my calculator gives me 43.8. So volume of the triangular prism is going to be 43.8 times 5. Overall, that gives me an answer of 219 units feet cubed, or cubic feet. So I got my final answer, my identifying piece, I have my partial calculation, and I have my other calculation. So bare minimum, at least the 43.8 to show what's going on. The more you show, the more partial credit I can give you, should things go wrong. I also will not give full credit for just a bare answer. I want to see the work. So that other prisms formula works for octagonal, pentagonal, you name it, it works for all prisms. Now what's a cylinder? It's essentially another type of prism that has a circle at the top. So again, you have this area of the base times height, and what's the base of a cylinder? It's a circle. And what's this? This is the area formula for a circle. So isn't this still just technically base times height? It's the same gig. You just have to pay attention and go slow. Think it through. So working this one through, first thing I'm going to say is, this is a cylinder. Check. Next, volume of a cylinder is going to be the area of the base, pi r squared, times the height. Next, pi is going to stay pi. My radius is given to me, right? And the question always is 18 equal to the radius, or is 18 equal to the diameter? Right? That's always the question. And the answer is, it's the radius. So I don't need to multiply it by 2 or divide by 2, right? I'm always thinking about cutting things in half, doubling them, right? Thinking it through. So my radius is 18. I'm going to have to square that times my height of 15. The rest of this is just literally PEMDAS on my calculator. And once I'm all set, I would say that this is 18 squared, probably be the first thing I do. So it'd be pi times 324 times 15. And then as I multiply across, pi times 324 times 15 is going to yield me a pretty large number, 15,268, round to the nearest hundredth, 0.14 cubic inches, right? So I have my values substituted in, final answer with proper units, the three pieces that I suggested. The name, at least some basic substitution of values, and an answer with units, and the proper units, right? It's as easy as 1, 2, 3. And at the end, we have a little bit of an application. And so what do we have? A diagram of Eric's pool is shown on the left, right? So you have this drawing. And it looks like Eric has a pool that's 4.5 feet high. Now he plans to fill the pool to a depth of 4 feet, right? So he's not going to fill the pool all the way because the water would spill all over the place. So we're just going to go to the 4-foot height with a garden hose that has 80 cubic feet per hour flow rate. How many hours will it take to fill the pool? Well, I guess if you want to know how many hours it's going to take to fill the pool, the first question is, how much water does Eric need? Right? We have to figure out how much water he needs, and then we can figure out how long we'll need to run the water for. Math, not just geometry, but this is about thinking, right? Thinking gets me fun jobs that pay well, right? So I want to try to process how to think, right? And I don't want to run from it. I don't want to memorize procedure. That's a waste of time and not our focus. Well, first off, a pool is essentially a cylinder. And if we're thinking about how much water, we're talking about volume. And we're talking about volume of a cylinder. So pi r squared, the area of the base, times the height. Now remember, not the volume of the pool, but specifically how much water Eric wants in the pool. So that's going to be pi times the radius. Now it looks like 27 feet is equal to the diameter. So half of 27 is going to be our radius. So half of 27 is 13.5. So that's going to be pi times 13.5 squared times the height. And again, the height that Eric wants the water, right? That's the desired water height. We're not filling the pool up to the 4.5. All right, now let's figure out what that is. So again, I would take the 13.5 and I would square that first, and I would say that that's pi times 182.25 times 4, right? Work with me. Don't copy. Copying is not a great idea. There's no learning opportunity to be had there. Then 182.25 times pi times our value of 4 gives us 2290 and 22/100ths cubic feet of water, right? So this is the answer to how much water Eric needs. Now, we know that for every hour, we get 80 cubic feet of water, right? So 1 hour, 80 cubic feet. 2 hours, 160 cubic feet, onward and upward. So if you take 160 and divide it by 2, you would get 80 cubic feet. Or if you take 160 and divide it by 80, you'd get 2 hours. So if I take the amount needed divided by the rate, I'll get my time. So let's see what this shakes out to be. Now, a lot of students will say, how do you know what to do? Well, you just get it because you're a math teacher. No, I get it because I've tried and failed enough times on my own, right? So try and fail. We have 2,290.22 cubic feet needed, and we're going to divide that by the flow rate of 80 cubic feet per hour. The units cancel out, we're going to be left with hours. So really it's cubic feet divided by cubic feet per hour is the same as cubic feet times hours over cubic feet, and those cancel out, right? So again, my knowledge of fractions is what allows me to deal with the units, right? So that's something from middle school that you should have. And I think that you need to keep working on that. So the 2290 divided by 80 gets me 28.63 hours. Not 28 hours and 63 minutes. That doesn't make any sense. That would be more than 28 hours. So we're just going to leave it at that. And that's more than a day. I recommend that Eric not run the hose. He should just order some pool water delivery. Anyway, you keep working, and I'll have some more problems posted on the board for you to work on. Okay? Good luck. Ask lots of questions.